Hi, I'm John Mills, CEO of SimuQuest. We're software engineers that develop tools for other software engineers. The particular software they work on is embedded in a product and controls the functions of that product. For example, the software in a computer that controls the steering of a car, or software that controls how a wind turbine responds to changing wind conditions, or that controls a medical laser device. A key goal for companies is to get to market faster than their competition with exciting new features that differentiate them. Today's cars are controlled by millions of lines of software deployed across network computers. All of this software needs to be tested to make sure it actually works with the hardware. And of course, it's much more efficient if you can model and test this first in a virtual environment before you build everything. That's where we come in. We help engineers build models to simulate their systems and software in a virtual environment. Our main contribution is to make tools that guarantee absolute consistency as the models and software are being developed. In this way, engineers from around the world can simultaneously work on the same software, meet requirements, and in an agile fashion, accelerate to the goal of having built and proven out the software. So that once it's in the physical world, on release day, it will be absolutely error-free. That's SimuQuest. We help embedded engineers on the quest to simulate their software and make it error-free, and for companies to get to market faster with unique, differentiating technology. By the way, for the embedded software and controls engineers joining us, you'll likely be familiar with the MathWorks tools, such as Simulink. Our tools work in harmony with these tools. And now, my colleague Gianluca Capraro, a project manager here at SimuQuest, will share a deeper dive with an example of how our Unify tool facilitates all of this.
Thanks for the introduction, John. Today, we plan to showcase Unify and highlight some of the ways this product redefines model-based and embedded development and provides a solution to developing embedded software with both agility and functional safety in mind. As John alluded to, Unify is an intelligent, centralized management tool that helps embedded software engineers collaborate efficiently on their projects, with the confidence that all of their development efforts will be kept consistent and the final product will be error-free. In the following demonstration, we'll see how Unify can import multiple existing Simulink models into the same project and then apply built-in automated rules and intelligence to quickly instrument the project and eliminate any inconsistencies. We'll then see how Unify can generate an integrated model that represents the entire architecture that we defined in Unify, effectively combining the two original, out-of-date models into one updated and error-free model. For certain applications, these processes alone could take months of manual effort, even with a team of engineers. With Unify, developers can bring legacy models to life and rapidly test their ideas in a fraction of the time. What we'll be showing today is only a small part of what Unify can deliver. If you're interested to learn more about developing with Unify, we encourage any viewers to reach out to our team, and we'll be happy to discuss. Enjoy the video. I will be using Unify to import an electric vehicle reference application to use as the starting point for this project. This model is provided by the MathWorks and represents an electric vehicle model with a motor generator, battery, direct drive transmission, and associated powertrain control algorithms. I can connect this model to my Unify project by creating a Unify connector block in Simulink. Then I can tag the components of the model to designate how I want Unify to import them. I also want my project to contain advanced driver assistance systems known as ADAS, such as adaptive cruise control, lane keeping assist, and automatic parking. I have previously created these as Simulink models and can connect and tag them for import into Unify as well. To import the models, I'll right-click the Unify project and choose the option to import from Simulink. I'll select the Simulink EV model for import and have Unify process it to scan its components. Upon import, Unify automatically creates each component of the Simulink model in the project as its Unify analog. I can repeat this process to import the ADAS models that will further enhance this application. Looking at the project artifacts after importing, I can see the EV application and ADAS components are now in Unify, along with their associated subsystems and features. I need to ensure this new application meets my specifications in terms of units, data types, and custom rules to enforce. I also want to add requirements and link them to individual project artifacts. I've created these resources in other projects and can use Excel to import them into this project. If data in the project then violates any of the specifications defined by the imported resource pools, UniFi will automatically let me know. We can already see that UniFi detects several errors in the imported models. These errors arose from violations of UniFi built-in rules or from an inconsistency that doesn't adhere to the design resources we added to our project. Rather than searching through the layers of each Simulink model to manually identify each error, UniFi pinpoints the source of errors and provides directions for how they can be resolved. Whenever possible, UniFi suggests automated resolutions that are available. Using this intelligence, I can quickly address each of the errors and instrument the project to be error-free and consistent in all aspects of its architecture, data, and interfaces. Once the project has been made consistent, I want to graphically validate the project architecture and visualize the data that flows between artifacts. I'll step into the architecture validation graph view to quickly look at how my artifacts are connected and verify my expectations. I can then commit this project to my server, where it will be version controlled, team members can access and add to it, and it will be run through our continuous integration testing environment. I now want to generate this updated EV application as a Simulink model. I can use UniFi's Model Creation Assistant to create an integrated model that represents the entire project architecture that was made consistent in UniFi, effectively combining the original electric vehicle reference application and the ADAS feature components into one updated and error-free Simulink model. After generating the model, I'll jump into Simulink to validate what was created. Here at the top level, I can see the EV application from the UniFi project, and within this application, I can see all of the subsystems that were defined as well, including the ADAS features. Diving into any of these subsystems, I can see that the corresponding features have also been integrated into the final model, and that there are no errors. I can now simulate the new model and observe its operation to confirm that it meets the requirements linked to my project. In this example, UniFi enabled me to combine multiple models that contained errors into one integrated error-free application in just a few minutes.